Hey, what's up, people? How are you? $10:08. Let's get started. Hope your morning is going pretty good. Alright, so what did we do yesterday? We learned more about garbage collection and memory management in Python through ChatGPT prompting. Continue working on SQLite tests to solve SQLite errors associated with potential file locking when calling OS remove after .close. After db.close, just to clarify. This to ensure the file is always not locked, which causes program crash exception. Is not locked when start remove is called, which causes program crash exception. Okay, and we stopped at line 520 in SQLite test. So let's pick up there. Let's go to line 520. We stopped there. Next, it says add try except prior to every OS remove in while loop to ensure file is actually not locked prior to OS file access. Probably should put this code in a small function, which is called every time instead of repeating code. In this, we would run .close, assign proper vars to equal none, and while loop with try except. Okay, that sounds good to me. So let's go ahead and do that. And also, don't forget that. Next, number 2. Okay, so let's go ahead and reset our extensions, reload, restart, whatever. Now, so we got rid of the garbage collection. We don't do that anymore. That code is gone. Instead, we're gonna use because it was pretty slow. So we're gonna use we're just gonna use a try except instead. It's just easier to do that. Alright, so let's go ahead and add the try except, and we're gonna do this every time we call. Wait, what happened to remove? Oh, there it is. Tripping. Okay, so we'll start at the top. So I gotta use page up and page down, like I'm trying to make a habit of using that. So this is going to be what's in the function, I think, because let's see how many times we do this. So we have, it'll probably be up here as well. Where is it? It'll probably be here because we're doing remove, which means, yeah, we're gonna need that code here as well. So that's 1. We have to fix that. That's a different issue. 2, and then we have well, this one doesn't remove. Okay, yeah, so I was confused. I was like, wait a second, why do we do remove again, and why don't we do remove there? Well, we don't. We do remove before we run a vacuum into, because we have to have the vacuum into. The vacuum into requires the file to not exist at the target path. So if it does exist, we have to remove it first, and then there's a sequence to do that properly, and that's close, set the DB and cursor to none, and then to remove the target path. Yeah, so it's going to be 1 and then 2, and then this one. Technically we could make the function have remove or not remove. So, like, you know, it might remove, it might not. We'll see about that. So that's 1, 2, 3, and then if we did this one, that would be number 4. That would actually be number 3. And then what else do we have? Do we have more? Or is that it? That's it? Just those 3? Well, if it's just that those 3, we might not make a function for all that, for that little bit of code. Let's see. We need the try except. So we would do try ray. Try to remove it, and then except. And in the case that we get an exception for this, we'll enter into this except, and we'll say, well, how about this? We'll say while file still locked, bool is equal to not locked is equal to false. File removed is equal to false, and then we'll just have file removed Okay, so let's review. We do close, then we do DB set to none, then we do target cursor set to none, then we do, well, let's verify. So we have DB, DB is equal to SQLite 3 connect at the target path. So we're creating the database connection, we're creating the cursor at the target cursor, is equal to DB cursor. New DB verified not corrupted is equal to false, while new DB blah blah blah. If target cursor is not integritous, if it's not good for whatever reason, after we have connected to it. So this is where we're creating the copy using vacuum into, then we're connecting to the copy. We're creating a cursor for the database connect. That's the copied database. Then we're checking to see if the new database is verified not corrupted. Once we check to see if it has integrity, if it is not okay, then we would do db.close to close the connection to the database. Then we would set db to none. Then we would set target cursor to none, and then file removed equal to false. While file removed is equal to false, that means we haven't removed the file yet. We try to use OS remove on the target path because it's corrupted. Because it's not equal to OK, that means it's corrupted. So then we would remove it, set file removed to true, which will break us out of this while loop. In the case of an exception, i.e. that file is still locked or whatever, then it would enter into this exception and print out this log, which is the save file, py file, abbreviated vacuum into integrity check recreate for the function name. This just some little details saying file remove, accept, and then it's error, and it's gonna add the line number and like the actual traceback to the printout, the log, through that function. That's what it does. So that method rather, and then we go ahead and recreate that database. But it's kind of silly though, because we don't check, we don't check the new one. So I don't think this would need to be in the while. We would do while database is verified not corrupted is equal to false. And then in this case, we would really want to check it again. I hate to say that, but it's sort of recursive, but like, yeah, that's basically what we would want to happen. But we could put this in a function, right? While the new database is verified is not corrupted. If it's not corrupted, then this checks if it's corrupted. Then we recreate it right here. So basically we want to have like a loop. We don't want to leave this loop until we verify that it's not corrupted. So in the case that it was corrupted and we did recreate using vacuum, we would really, well, let's see, it would, okay, so it would recreate, and then since it's still in the while, because we haven't broken out of the while, because this new DB verified hasn't been changed to true, That only gets changed if it is integritous. If it has integrity, whatever the fucking word is. I don't think that's a word. Anyway. So it's vacuum into target path. It's going to enter back into the while because it's still set to false. Then it's going to check the integrity, and it's the only issue here is we don't have the target cursor and the database connection. So I think what we should do is put these two lines in the while loop, because that will make it to where when it redoes it, it will reuse these lines. Does that make sense? Like so. It's gonna do. It's gonna create the copy using vacuum into target path. Then it's going to set new DB verified not corrupted equal to false to get us ready for the while loop. Then we're going to enter into the while loop, and then we create the database connection right here. We create a database connection. We create a cursor. Then we check to see if that database is valid. If it is not, then we close the connection to the database, set the database to none, target cursor none, file removed false. While file removed is equal to false, we try to remove it. Then we set file removed to true in the case that it is now removed. Then we do then in that case it goes down here and it's going to recreate that target path copy again, and now it's going to go right back to the top of the while loop. It's going to recreate the database, because remember, this is a new database. It was just created, so we have to create a connection to it. We have to create a cursor for it, and then we will check to see if it's valid. And if it's valid, it would go out down here to else. Well, actually, no, I'm sorry. I got mixed up here. It would create the new database copy. It would establish the connection, establish the cursor, and then if it wasn't integritous, it would just do that process over again, re-delete it, and then recreate it, recreate the connection, recreate the cursor, use the cursor to check for integrity. Now, if it is valid, if it's not corrupted, in that case, it would go over here, and it would go to the else clause, which would close the connection to the database, set it equal to none because we don't need it anymore. It's basically it's a throwaway connection. Now we still need the file, so we're not going to run OS remove in this case, but and then we can set new DB verified not corrupted equal to true, because now we know it's valid. So then it will finally break out of this. I know that's a lot, but honestly, like, that's the bulletproof way to make sure that what we're doing is rock solid. So it's the correct way to do it. So what do we need to do as far as like moving things to be in a function? I don't know if we will, because we only do this, well, we do it what, 2 or 3 times? We would do it here, 1, 2, and I thought there was a third. Why did I think there was a third one? I'm like pretty certain I thought there was going to be a third. I only see, well, yeah, we have this one, and then this one. We don't need this section. We don't have to check the integrity. We don't have to run any of this stuff in the case. So I don't think we would use that function for this. because it would have to be a heavily modified function to only execute this in one case and then execute all this other stuff in another. That's kind of silly, right? So I think this we would just leave as it is. So in that case, then we would only have 2 instances of it. And it is a lot of lines, so maybe we would want to run this function, turn it into a function, that is, instead of doubling up this code, because that is a lot of lines. It's like, so let's just go ahead and modify it, and let's see what we get. So we have the OS remove. We're going to change this to be, if OS path exists, then while file removed is equal to false, we have to redefine that as well. So I hate when it does this. That's one thing I don't like about VS Code, is it jumps to like where the line, where the beginning of your text on that line is. I hate that. I remember Adam did not do that. Like, I don't know. It's a weird thing. I don't like it. So while file remove, so that means we have to move this up here. We need to well, we might not have a database connection, so we might not have to close this database connection, right? Okay, so this is a little bit complicated, I'm not gonna lie. It's a little bit, it's a lot of variables, right? You know what I mean? But I like to use functions, but they do reduce lines, but sometimes they can increase confusion and complexity a little bit more. Because I'm not sure if the context in which this function would be called whenever it would go here. The question is this connection actually open? Like, is this an open DB connection, or when it enters this section, does it simply, let's see, is this an open DB connection, or when it enters this section, does the DB connection exist at all? I.e., the file exists, but the DB connections don't. So there would be, so if connection is open, ensure setting DB non-cursor. So that's the question we need to figure out. We have to figure out whether or not let me see something here with this exception. So we have DB target cursor. This is the new database has been created. The new file, that is the copy, has been created. Now we create a connection. We create a cursor. We check for integrity. If it's not, we close it, set it to none. do the while loop to try to remove it. If it gets removed, then that's great. We do OS remove, and now it's gone. And then, well, that's it. We closed everything out, we set it to none, and we remove the file. We break out of this loop, and that's a done deal. But if we try to remove it, but we hit an exception, and the file's still locked, it's gonna enter. What's it gonna do next? Well, it's gonna stay in this loop. It's just gonna stay in this while loop. And that's not good. I think we should probably put these lines inside the while loop. So while the file is removed is equal to false, we would try, and that we should try to close it, do db none, target cursor none. But I guess really we don't need to put that in the while loop, because it's gonna run all this prior to this while loop. So once it tries to remove, really the only case I can think of that it would hit an exception would be if this OS remove is trying to access that file, but it, for whatever reason, hasn't finished closing yet, which would keep it locked. In that case, OS remove would when we try, it would throw the exception, and then we would really just need to wait like another couple microseconds or whatever for the file to be like finished being unlocked or whatever. So we would just basically continue to try this. If there was some weird scenario, I guess this would be like an infinite except, and this would just be like an infinite while loop type deal, and that would be ugly. But at least we would have this continual log that would print out, so that would let us know if that happened. So I think so far, I think this is good. So since we okay, so either way, if it's integritous or not, we still close it. So I was trying to see if we could put db close and db equals none and stuff. We could put this like outside of the we could put result, we could put integrity, we could assign this to integrity result, and that would hold on to the value. Then we could close the database, and then we could do the if else, so we don't have to duplicate this. Yeah, we duplicate this code. I hate duplicated code like this. It's terrible. So what we're gonna do is we're gonna do like this. We're gonna say this is gonna get copied, okay, and then this is gonna be a db okay or not equals, and then we say if db, so this is now saved, like this is gonna return something. So once it gets returned, it's there. Now we can delete the target cursor of the database, and it's not gonna affect this variable. This is always gonna remain whatever string it returns, okay or not. So we can then go ahead and do db close db equals none right here, because we don't need this connection anymore. We can close it. We can set it to none. We can also set the target cursor to none because we don't need the target cursor anymore. And then we can do like that means we don't have to see, we don't have to double this like that. So we can do while DB new DB verified not corrupt is equal to false. We create the connection, we create the cursor, we check to see if it's okay or not. Then we do database.close because we're done with it. We do DB none, target cursor equals none. If DB okay or not is not equal to okay, then that means it is corrupted. Means corrupted. Then we would set file removed equal to false, while file removed is equal to false. And we could just do while true. While true, and then this would be break. Instead of having that extra line, file removed, like it does to give us a little bit more description. We can just say breaks. Like we don't even need to describe this. This is like we don't need to describe this. Okay, it's fine. We don't need to have a descriptive variable and an extra line. We just don't. It's pretty simple. You do while true, try OS remove, then you break, except, you know, you would do it again. And I guess we'll just say this while loop is for in the case the file is still locked from when db.close was run, since there is a small chance, supposedly, I don't really know if this is supposedly, that it could take some time for the OS to release the lock on this file. So this will just brute force over and over until that file is released, and it will delete the file. Yeah, so there you go. So we do, if it's not okay, we enter into the while true, we try to remove. If it doesn't remove, which there's the exception, if file is still locked, most likely scenario. Still locked from our db.close call. This is the most likely scenario. Then it throws this exception. And I'll just put file may still be locked. Is probably still locked. And then we'll try again. We'll try again. We don't really need all that, but you know, it'll help me understand when I see the if I see it in the output. Okay, so if db is okay or not is not equal to okay, then we enter while true. Got you, that's good. Then we try, that's good. OS remove, target path, and that's correct. Target path is the one we want to remove. Okay. Then we would break because that database the corrupted database was removed, and then it would go to here. It would go to this line to recreate the new one. Then it would go all the way back to the top to recreate that database connection, the target cursor, and then it's gonna get the value of whether or not it's okay. Yeah, cool. And then it's gonna close that database, set the DB and cursor to none, then check to see if it's okay, and it's just gonna, hopefully that time it will enter into the else, and then it would just now this one I will leave the descriptor for, instead of doing just while true and then break. We'll leave this descriptor. And you know, how about this? This is just cleaner. Nice, short and sweet. While true, checks if new database is corrupt. If so, reruns until verified not corrupt. About this, even better. Runs until new DB verified not corrupt. Shorter and sweeter. It's just so much. It makes a difference. I'm telling you. This little, like, it does. It does. Okay. All right. While true runs until DB. So DB target cursor, DB okay or not, DB close. So this is in the correct location. This is in the correct location. And why do we have this? To free memory. And this is the same thing, to free memory. And there we go. If DB is okay or not, it's not equal to okay. Why is this white? It means it's corrupted while true. For case where file still locked from DB close, call from prior DB close, call. Reruns until file unlocked. Much better. Okay. This is about as clean as I can get it, I think. This is basically as clean as it gets right there. See, now when you have a bunch of revisions like this, it does become a little bit difficult to do review. You have to do review again. We're 42 minutes in. I forgot to do my timer, so we need to set it to 26. 26. There we go. All right, 26 set. Okay. Let's do CD Canasta. Testing. We'll do SQLite test, and this is probably going to throw an error. Unique. That's because we probably didn't delete the database files first. Yeah. Let's delete them and then let's rerun it. Okay, there we go. It worked. Let's make sure we have our 3 database files, and we do. And they return the correct values and everything. So so far this is good. Where do we have a problem? Well, I mean, we don't really need to. Let's see. Okay, let's go from the top here. Vacuum integrity check, recreate, take self target path abbreviation string. If target path abbreviation string is equal to S for stable, target path is stable path, else target path is backup path. If OS path exists, okay, so if that file exists, let's just say, well, let's just keep reading. I don't want to go into scenarios yet. File removed equals false, while file removed is equal to false, and we can do the same thing here. We're just gonna say while true runs until file is removed. Bam. So while true, it will try to remove it, except it hits that exception wherein we needed to copy this one and put it over here. So while true, it's going to try. It's going to remove it. It's going to accept. It's going to have the same error. Okay, because this is for, let's say we're going from save to stable. So if stable exists, we're going to try to remove stable database because we have to do that before we can run vacuum into. So we do while true try, and then we remove except, and it would just continue to do this over and over until it finally gets it. And but why would it? Okay, so we might not need this. We might not need this here because we only need this while loop if we actually if it actually exists. The connection. Only need this while loop if the database connection is active / assigned / open. Otherwise, if just the file exists, we wouldn't need to try except. Well, what if there was another scenario in which case that yeah, like the only case where we wouldn't run this, I mean, I'm trying to think, like, why else would we need a try except here? If the file was opened by something else, this wouldn't work. But really, in reality, the only reason that this file would be open is if we had it locked through SQLite, the database connection. And really, I don't think a file is locked unless the database, like, you can have a connection without it being locked. Let me ask about this. Let's see. Python SQLite 3. If you have a connection to database but aren't operating on the DB file, is the file locked from running os.remove? Yes, if you have an active connection, the file will be locked, or at least in use by a SQLite. You won't be able to delete it on most operating systems. It might technically allow deletion, but it can cause undefined behavior. So, operating system with a connection to open. What operations are being performed? Read-write interactions. Example on Windows. Connection and then try to OS removed exception. Output on Windows. Oh. Always close the SQLite connection with con close, then call. Okay. Okay, so actually, yeah, basically, DB connection is either still open or db.close hasn't finished on OS. Unlocking file on OS. Okay. While true, runs until file is removed. Try. Accept. So in this case, we would need that connection. So maybe we could do a con arg and then default it to none, and then check to see if con is equal to none. Yeah, that would be one way to do it. Oh, okay. So basically, if it well, that still doesn't fix the problem. Like, we still would need access to the connection to close it. Make sense? Okay, so let's run through the scenario because this scenario just might not require that. Let's we might be just like wasting time. You know what I mean? So let's read through this real quick and run through the scenario. So if the stable path exists, we try to remove it and then we vacuum into that path. Okay, and then we verify. This basically just verifies that the DB is not corrupted. And I can just div this out and have a little section, and we'll put let's say below section 421.25 verifies that the new DB is not corrupted. Ensures it is deleted and recreated if so. Yeah, so that's what we have these sections for, and that helps us to understand where each section ends at. So we know this whole section handles the verification of the new database being not corrupted. It ensures it's deleted and recreated if so. Alright, and now this one. If target path so I would say below section here. How do we do this? Creates well, it would say removes and removes old DB file and creates new copy with vacuum into. Removes old database file and creates new copy with vacuum into. Yep. That simple. There you go. So let's go up here and div that out. Alright. And then this function handles creation, or handles all logic associated with DB vacuum into operation. And it's all actually do vacuum into operation. Yeah, there you go. Okay, so there we go. Everything's nice and like pretty. The last question we have is going to be, and I think we're going to change this target abbreviation back to just straight up target path, so we don't even need to do this stupid shit where we refer to it as a abbreviation. We just pass the path directly to it, because we know at the time when we're passing it what it is. Like, there's really no reason to like add another layer of complexity. So this will probably get removed, and it'll just be if target path is equal to blah else. Well, actually, we won't need an if else at all. This would just get deleted completely, and it would just have just this: if OS path exists, target path. Okay, so we'll right here. Quite certain we can change this back to be target path arg and remove this if else completely. Yep. All right. Now what? Okay. OS path exists, target path, blah, blah, blah. So that's the question. Is this an open database connection, or when it enters the section does the database connection exist at all? So let's look at where it's called first. So we go up here, and it gets called first in this context with S being passed. So we're gonna look at this. All right. So we have our stable save state function, which takes checkpoint ID. We serialize it. We add that to the database. Then already created new backup equals false. Okay. If OS path exists, save data stable path. So if stable exists, we check to see if backup exists as well. If both of them do, then we create a connection to the backup, a cursor. We check to see if it's okay. If it is, then we have a valid backup at least to fall back on. We then run this vacuum into integrity check with S for stable, and that is going to go here, and it's going to say if OS path exists. So if in this case the stable path would exist, okay, so so in this case stable path does exist. So then we would go ahead and let's see, if OS path exists, then it will try to remove this target path. Now in this case right here, there is no database connection established to DB stable. So we're actually okay to we're actually safe to not close the database. Okay, now next one. In this case, where we have OS path exists, stable exists, but backup doesn't exist. Why does it say already created new backup? So if stable, I'm confused by this. If we have stable, but if we don't have a backup, why would we change? Why would we change this to already created new backup equal to true? and then run. Okay, because it's happening after. So really we should put this after, because then we create the backup, then we create the stable. Does that make sense? So that will make sure we don't run this again. Okay, I got it. Alright, so stable exists, backup doesn't. We go into the else here. Once we go into else, that's going to run this for B and S. And in this case, there shouldn't be an open connection to backup. In this case, there shouldn't be. Because remember, they're throwaway connections. We're supposed to close them immediately after. So what we really need to do right here is to be extra safe, is to make sure this connection gets closed. So we'll change this to be DB is okay or not equals, and that should be, yeah, DB backup cursor execute. So that if the DB is okay or not, then we say if DB is okay or not is equal to okay. Now at this point we can do DB backup equals none, and we'll actually do DB backup dot close, then DB backup equals none, DB backup cursor equals none, to free memory. This is to free memory, and this is to free memory, and release file lock. So yeah, we do database backup, create the connection, create the cursor, use the cursor to check its integrity. Then we can close the connection, then we set it to none, the DB to none, then the associated cursor we set to none as well, and then we just check to see if DB is okay or not. If it is okay, then we would, well, that's a different scenario, isn't it? We actually would be, we took care of this scenario. We're worried about a different scenario here, and that is the else. We would do B and then S. So we would run this because we have stable but we don't have backup, so then we create a new backup, and then we would create a new stable. So let's go and run through this second scenario for B. So it would enter into here, it would say target path is backup if it exists, which we already know that it exists. So another question is, do we actually need this line, or do we already know that they exist? Below line, do we actually need this line, or do we already know that it exists in every instance, in every case in which this is called? Because we might not need to check it at all. And like, I don't like extra bloated any dead code, as you can see. That's just how I roll. I like my shit to be nice and neat and 100% before I move on, so that I don't have to touch it again. It's gonna be clean. I'm not gonna throwing up some shitty buggy code and then spending half my life debugging it. That's just not how I do. I learned my lesson. That's a stupid way to code. You can code that way if you want to and feel like you made a lot of progress, but have fun spending fucking 6 hours debugging 2 lines of code that you know you just didn't take extra 2 minutes on. Been there, done that. Okay, one more minute. I'm gonna take a break. I'm a neck, dude. My neck's killing me. All right, let's finish this. One more minute. It's the last thing we're checking, and then we're gonna go. So we're gonna say vacuum integrity check B. So it's gonna go here. In this case, it's gonna go check to see if the path exists. In our case here, this path doesn't exist. It does not exist. Okay. Well, yeah. So that means we haven't created a backup yet. So this would be the first. We have stable but no backup. So then it would enter into this one. It would check to see if the path exists. It wouldn't exist. Then we do while true, try OS remove. We don't need to check. We don't need to close this connection. There shouldn't be an open connection to B, because in this case it doesn't even exist. So we're safe on that scenario. Then we have the second call where we pass in S. This one, same deal. We shouldn't have a live database connection to stable at this point, because we don't open it. It shouldn't be open at all. So in this case, we would not need to close this connection. Like, it should already be it should be able to run and close this file without any issue whatsoever. So I think we're gonna just remove the while and the try, unless, you know, in this one of these we need it. So that one we're safe, that one we're safe. What was the first one? That one we're safe. So now we need to check this one. So else. So if stable doesn't exist, so if we only have save data, that means it's our first time copying from save data to stable. Then we would do, and shouldn't we do stable first and then backup? Because that would throw us into that scenario where we have B but not S, and that's just kind of confusing, isn't it? So this should actually be S first, then B, because we want to make stable first and then backup. So if we have stable but not backup, it would flow with this logic, because we would have stable but we wouldn't have backup. Because in the case we might have backup but no stable, and it checks stable first. So if we had backup, it would go if stable, but it would enter else, and then it would create stable. So actually it would work. And then it'd say if already created new backup. And I'm looking at this and I'm like, couldn't I just reform this to remove this already created new backup and just do SB, SB, SB? Because that's 3 lines. That would get rid of 1, 2, 3 lines. It's already like, it's a better system. It's easier to read, you know what I mean? Like, this is more confusing, and it's the same amount of lines. So if we're always gonna need to create a new backup, like that's how we do it. We do S and then B, S and then B. Why don't we just do it that way? So let's just get rid of this, create a new backup altogether. Okay. Then we're gonna do already created new backup is gone, and then get rid of this already created new backup, and then every time we just do SB, which this is making me feel like since we already do SB, why don't we just do why don't we make it happen internally to where it just does both of them? You know what I mean? Instead of calling the function twice, why don't we just make it to where it handles that in the function? Either way, I mean, like, since we always call this function 2x, why don't we just add the second part of the call inside of the function itself? So then we just call function 1x and it creates both stable and backup internally. Yeah, that makes more sense, honestly. And just to verify, this is the correct like logic here. So we have, let's see, yeah. So before we mess with this, all right. So we had, it would do S and then B, because always creating a backup would be false, so it would do S first here, then it would go down here and do B for backup, because already creating a new backup would be false because it hadn't been changed. Then in this case it just does SB straight up, and then in this case it would do S, and since already creating a backup is still false, it would do B as well. So yeah, every time it goes SB, it doesn't matter. Like there's no reason. See how like better. It's easier to read like this. It's better all around. So we'll leave it as is. And we do have to increment that checkpoint ID. We need to return that checkpoint ID. Okay. I'm feeling pretty good about this session. I'm ready to, honestly, I feel like I could just keep going a little more, which is rare. I usually don't feel that way, but right now I feel like I could just keep going a little bit further. So let me finish this. Okay, so didn't we verify? So yeah, basically we can just look at this function now since it's so simple, and in none of these cases would we have an open connection to stable or backup, which means every time that we ran this, it would not be an open connection, which means we don't need this while loop. We don't need to try. It will work. Like, it's just like everything else. Bam. So yeah, then we do subcursor vacuum into. So then the next question is, now why do we, oh, to see if when it's locked from db close, right? Technically that could be the case for when we did db backup close and then none. Technically that could be the case. Ah, yeah, because we're running backup close. We'll leave it as is. I don't think we'll ever have an issue with that. And if we did have an issue with it, it would just crash the server straight up. It wouldn't be some weird intermittent bug. Like it would be pretty apparent, like, because it would try to remove it, and it would tell us exactly what the problem was. It wouldn't be one of those like nightmare bugs, you know what I mean? So like I would just say we're just gonna assume that it's working as we expect it to, and that it's fast enough, etc., that we don't need to run the try except on it, because it just gums up the code, you know what I mean? Okay, vacuum integrity takes create, and so let's figure this out. Do we actually need this line, or do we already know that it exists in every case? So for this one, target path, OS path, target path. In this case, does S exist? So it does exist in this case. Does B exist in this case? Well, yes, we know in this case they both exist. But in this case, we only know that stable exists. In this case, with B, we don't. We know that it doesn't exist. So it is a variable. Like sometimes the target path, does exist. Like in this case, the target path exists. In this case, the target path exists. In this case, the target path exists. But in this case, the target path does not exist. You see what I'm saying? In this case, this target path for B, it doesn't exist, right? And then in this case, neither one of them exist. Or at least we know this one doesn't exist. This one technically, what did I just do here? Technically, this one could exist. Well, actually, I don't think it could. Not since we fixed the order to be S, then B. So, yeah, this is basically, in this case, path doesn't exist, but in all these other cases, does exist, doesn't, does exist, does exist. So it is a variable, so we have to say that this line is necessary. This line is necessary since it varies on whether path exists or not when function is called function is called. We don't have to. Less is more, right? This line is necessary. It varies. If path exists, or we say varies if path exists or not. So that's implied. So we just say this line is necessary, varies if path exists when function is called. Varies whether path exists. Boom. Great. Alright, now we do OS remove target path. Okay, so this is taken care of, and then the last thing we're going to do here is this. So we're going to change this back to target path. So instead of doing this stupid ass, and I think I had this in things to do. Garbage check 4 DB closes. Determine the solution sectors and blah 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 blah. Determine the DC when the next issue. Yeah, so we took care of that. Timestamp last save apply section insert notes are probably concerning proper save logic and client buys apply section. I have no idea what that's talking about. Ensure broadest scope. I hate this part of the stupid ass shit. Sounds like ass. Who decided to chop and screw that up? Yeah, when you chop and screw it, you screwed it up. It's not good anymore. All right, pressing issues. Your broadest scope first for save system logic stable. I know I added this in. Maybe not. Whatever. It's not important. Let's go over here. Test reminders. Do we need this? Why do we even have this? I know we need to create a few more test segments because it's looking kind of sparse. How many spaces do we put between each one? 1, 2, 3, 4. So that means we need to go to the end and then go 1, 2, 3, 4, 5, paste. 1, 2, 3, 4, 5, paste. Bam, there we go. Alright, now we can close that out. Go back over here to SQLite test. And what else are we doing? I just did something. Okay, got rid of that. And then, so target path, yeah, we're gonna change this back to target path, right? So let's find all that. I thought we had the descriptor for the function. Oh, we do here. Target path abbreviation string. So this is going to go bye-bye. This is just going to be target path. And then this is just going to be string path. And this is going to be the path string of the database file that we are creating via vacuum into. And this is just be, we'll just say stable or backup. Boom. And this is just gonna be, we're not even gonna do the if else, we're just gonna do straight up if OS path exists, target path. And then this is gonna get changed to target path. Abbreviation string. We're gonna paste in target path, and we're just gonna go. So this is gonna get changed right here. Oh yeah, this is where we put the note. I think we should change target path into path. It makes more sense. Yeah, there we go. To close it, since they have been determined to be throwaway. Okay. We're kind of scattered. I'm not gonna lie. But I know what I'm doing here. We're a little bit scattered with how we're doing this, but overall, I think I got this figured out here. So no more results for that. Okay, cool. Now we go back over here and we do the same thing. Target path abbreviation string is gonna instead be target path. So we're going one at a time. Target path, target path, target path. But here, we're not even gonna do this. We're just gonna check if path exists. Now look how much better this is. Look at this. Look how short and to the point that is. Bam! I love it. And we don't actually need that div at the end because it's the end of the function. Yeah, so this is so much better. We just check if path exists. Then we remove it. And I did verified that verified in all cases this function is called there should not be any open DB connections, therefore we shouldn't have to worry about the file being locked, i.e. having to use a try except here. Yeah, there we go. Alright, cortex vacuum into while DBs. Well, let's just go ahead and run it. Actually, first we're gonna do this. We're gonna change this to be self path, like so. We're just gonna pass that in. So this is gonna be stable path. Then backup path is gonna be this one. Go right here. Then go back up yonder because we're gonna do S again. Whoops. This one is going to paste it in as well. It's going to be stable backup. I can't type at all. Help me. Then we're going to go here and then save data stable. Save data stable. Back up path. There we go. Now, let's go ahead and so this runs until new database verified not corrupted. It creates the connection cursor, gets whether it's okay or not, closes, sets back to none. If it's not okay, we do while true, try to remove, and we do have to. I mean, theoretically, this is the same scenario as before where we said we wouldn't need to do this try except. So, I know I went through this process of adding the try except. But, I kind of want to just not, because I remember it wasn't, that actually wasn't the bug. And I know that would seem silly to undo the work that we did, but this is just the process. This is how it works. It's like it's an art, you know. You it is what it is. Just because I put it up there doesn't mean I can't take it down. Granted, I try not to put anything up there that I'm gonna take down. That's a big part of my programming principles, but I think here what we'll do is we're just going to go ahead and we're not even going to worry about this DB not being closed. We're just going to assume, right? So we're just going to do, if DB is not okay, we're going to remove. There's no break. There's no exception. Then there's none of that. And look how much better that looks. We just do remove, then we recreate it if, and then we have no else. If it is not corrupted, we just don't do anything, right? If it's not corrupted, then we're good to go. So look how short and sweet this is. While true, DB target cursor, DB okay or not, closes it, sets it to none, target cursor to none, free up memory, checks if it's okay. If it's not okay, remove that path, and then just recreate that, redo it again. Oh, but we do want to make sure it's not exited out until it's we do want the while, so we're gonna keep the while but remove the wait a second. We want the while. Okay, no, we still have the while. I'm tripping. Alright, yeah, so let's look at this. While true, it creates so it vacuums, then it goes ahead, and we don't even need this as a section anymore. Like, it's not even a section, it's just, it doesn't even need to be described anymore. Well, I'll just leave that, it's fine. So we do while true db target cursor db or not, db close. If it's not okay, we remove, then we vacuum, and then we do L, then we would recreate the connection to target and then do it all over again. Okay, so we need else break. We do need the break, which means this means new db not corrupt verified corrupts. Yep, so while true, and then else, so db is if it's not okay, remove, revacuum, do it again. Otherwise, if it is okay, it will eventually break out. There we go. That is clean. Look at how clean and beautiful that code is. Great. So we'll say that this will be the next thing to address. And we're really like getting close to the like this is basically perfected, this section. I really don't think I can improve this anymore, and going over it again and again just helps me to verify that it's good code, and we're not gonna have any problems with it. So I spent a lot of time on it, a little bit more than I wanted to, but this is gonna really make sure like this is gonna help me to make sure this code is good when we put it into the actual project, and we're not gonna have to worry about something's wrong here. Okay, so we got a bug going on here. It says, let's try it again. Wait, why do we have B and oh, okay, I know the problem. I see. I got you. I know what it's doing. It's down here. That's the problem. This is going to be stable. So this is going to be database dot data stable, and then this one's going to be database stable backup. And I think that should do everything. So it created B and S because I'm a doofus. I see what I did there. Now let's try it again. There you go. Bam. And it creates save data stable, and then save data stable. I'm sorry. Save data stable, and save data stable backup. Great. So let me just put a note right here. Say note for 2125. Need to copy and paste code from new and improved code from SQLite test py to this files associated sections. Yes. Alright, now I like this chiptune. This is some good chiptune right here. Some good chippy tune right there. Yeah, so I think we'll go ahead and take a break now. Add try accept, so we did that. Close, we took care of that. I made changes to finally reflect save logic, so just continuing. Adders, be careful about where changes. So this is going to be called next. And basically copy this and just paste it over here. Next. 21. Need to copy and paste improved code from here. to save logic.pies associated sections. So we need to copy and paste into improved code. From this file. Okay, good. So 441 in SQLite test. Whoa. Whoa. Alright, now let's cd out to the root of the project directory, which we have. Let's do git branch, make sure we're on the right branch, which we are. Git add to stage everything, git commit -m, paste in this devlog. There you go, successfully committed. We do git push to push to the GitHub remote repository. There you go, that's done. Now we can go ahead and Open up this programming projects. We'll copy this one. We'll back out. We'll go to the backup. We'll delete this. We'll paste in the new one. And then we enter in, go to devlog, go to the end just to verify it is correct, and it is reflecting the latest updates, which means we did everything correctly. Now we can change the date of the folder to reflect today's date, which was the last time we updated the local copy. Alright, so that's going to be it for me. I'm going to go to the gym. I don't feel like it. My neck hurts like a witch. I'm going to take some more ibuprofen and stuff. And today's heavy bag day. So, yeah, we're going to go do some heavy bag work. And, yeah, that's pretty much it. I'll come back. We're going to do some more code. And it's from work probably. Got some fucking like grease shit on my face. Gross. Anyway, yeah, so we'll be back. That's the plan anyway. I have a dentist appointment at 4 o'clock, so I'm gonna go to that. Anyway,